Hello, welcome on. Here we are going to discuss about the topic related to understanding in CA. What makes understanding hard? Understanding is constraint satisfaction. And at the end we are also dealing with what's algorithm. These all topics are related to CA while we are making one program to solve a particular task. It is difficult to take inputs such as speech, text, and images. So, for as a system we created to solve a particular problem, this may be hard for the system to take input and understand what kind of input is taken and how it is going to be transformed from one representation to another to solve that particular task. Understanding is a crucial aspect of computational intelligence. So let us start with understand and understanding in general. Here are some definitions for understanding as per dictionary. The first one is know or realize the intended meaning of words. Know or be aware of the importance or cause of. Know how someone feels or why they behave in a particular way. Believe to be the case from information received, sympathetic awareness or tolerance. A person's judgment of a situation or an informal or unspoken agreement. Here, the last four definition shows the emotional level of understanding that dealing of computational intelligence or mission is hard to deal with. Next, understanding terms of CA. What is understanding? To understand something is to transform it from one representation into another, where the second representation has been chosen to correspond to a set of available action that could be performed, and where the mapping has been designed so that for each event an appropriate action will be performed. There is very little absolute in notation of understanding. Success or failure of an understanding program can rarely be measured in an absolute sense, but must instead be measured with respect to a particular task to be performed. Which means it is hard to measure the level of understanding in CA, but instead we can measure understanding level by how accurate or how computer performed the given particular task. So we cannot measure the success or failure of understanding accurately. It can understood only from the action performed by the CA device or computer. Here, the example is interpretation of the sentence I need to go to Mumbai as soon as possible by airline reservation system and family friends. The system will have understood if it is find the fast available plane to New York. If you say the same thing to your best friend who knows that your family lives in New York, she will have understood if she realizes that there may be a problem in your family and you may need some emotional support. From here, it is clear about the difference between understanding a level of a computational device and a human being. The system understands the problem in a logical way and only gives solution which just we ask or input to it. But the friend gives support at emotional level as well as she can support logical level also. The computer understanding applied to images, speech, and text. What make understanding hard? The first one is complexity of the target representation into which the matching is being done. The second is type of mapping that may be one to one, many to one to many, or many to many. The third is level of interaction of the components of the source representation. The fourth is presence of noise in the input to the understand. Complexity of target representation. Suppose that English sentences are being used to provide input to a program that records events so that it can answer a variety of questions about the events and their relationships. Consider the following story. Bill told Mary he would not go to the movies with her. Her feelings were hurt. The result of the understanding this story could be presented using conceptual dependency model. This representation is considerably more complex than that for the simple query. Constructing such a complex representation is more difficult than constructing a simple one since more information must be extracted from the input sentences. Extracting information often requires the use of additional knowledge about the word described by the sentence. Which means when we input simple query, it is easy to represent, but when we using conceptual dependency model to represent it, it becomes more complex. And we need to extract information which need additional information about the input words. For example, the previous case of Phil and Mary, the conceptual dependency representation is shown here. It is complex representation and hard to understand. Type of mapping. As we already say, understanding is a process of mapping an input from its original form to a more useful one. Simplest kind of mapping to deal with is one-to-one. That is, each different statement maps to a single target representation that is different from the arising from any other statement. Very few input systems are totally one-to-one. Consider the following language of arithmetic expression in a programming language, that is A equal to B plus C star D. In computer language, it is represented like this: colon equal to A left hand side plus B left hand side star C and D. The human brain can compute large sum very quickly, but using computational intelligence, we make electronic or digital machine to able to make a calculation and then to determine what to do next. One-to-one mapping, they are generally simplest to perform. They are rare in interesting input system for several reasons. One important reason is that in many domains, input must be interpreted not absolutely, but relatively with respect to some reference point. When images are being interpreted, size and perspective will change as a function of the viewing position. Thus, a single object will look different in different images. Example is pictures taken too close to the scene and pictures taken from further away. Here, this picture is taken close to the scene and this is taken from further away. The relative differences in picture of the same scene is shown here. Many-to-one mapping. Natural languages both in spoken and written form require many-to-one mappings. Speech, no two people speak alike. In fact, one person does not always say a given word the same way. Speech spectrogram of the same word looks different. All the following sentences will map to the same search in a English frontend to a keyword data retrieval system. That means natural languages both in spoken and written form require many-to-one mapping. Example is in speech. We know that no two people speak alike, so the natural language processing requires many-to-one mapping. Because a given word can be expressed in a different way, it may different sound frequency, and we may add different words to get same search result. For example, if we want to know about presidential election, so how we are going to search? Yes, we can search in different way by using different words as shown in here. But the keyword here is election and president. For example, we ask the same question different way here. Tell me all about the last presidential election. I had like to see all the stories on the last presidential election. I am interested in last presidential election. But here the keyword is election and president, right? Next is one-to-many mapping. It is often requires a great deal of domain knowledge in order to make a correct choice among the available representation. Example, differences in speech signal. They are flying planes. It can be expressed in the following ways. They are flying airplanes. They are flying airplanes. They are flying planning tools. They are flying planning tools. The sentence in isolation is ambiguous. Clues both from previous sentences and from the physical context in which the sentence occurs usually make one of the interpretation appear to be correct. So here this is the opposite to many to one. But here we require a great deal of domain knowledge. From the available many representation, one representation is here chosen as correct result. Next is many to many mappings. English has the property of many to many mappings, in which there are many ways to say the same things, and a given statement may have many meanings. That is, we can express the same thing in many ways and can have many meaning to it. Level of interaction among components. In most interesting understanding context, each input is composed of several components such as lines, words, and symbols. The mapping process is simplest if each component can be mapped without concern for other components of the statement. It means each component is independent or mapped without concern for the other component of the statement. Then the mapping process is simple. In many natural language sentences, on the other hand, changing a single word can alter not just a single node of the interpretation, but rather its entire structure. Programming languages provide good example of language in which there is very little interaction among the components of the input. Components of English sentence typically interact more heavily with each other than the components of the artificial languages such as programming languages do. Here it means mapping is simple if each component is independent. The programming languages are a sample for this. But in the case of natural languages, changing a simple word can affect or alter the entire structure of the meaning of the input sentences. So here English is the example for natural language. English sentences typically interact more heavily with each other components than programming languages do. Here is the example is John saw the boy in the park with a telescope. John saw the boy in the park with a dog. John saw the boy in the park with a statue. Here various components are interact with each other this in this different representation. Now, in the input. Understanding is a process of interpreting an input and assigning it meaning. In many understanding situations, the input to which meaning should be assigned is not always input that presented to the understander. Because of the complex environment in which understanding usually occurs, other things often interfere with the basic input before it reaches understander. We must take an input signal and separate the speech component from the background noise component in order to understand the speech. In image understanding, if we look out of your car in search for a particular store sign, the image you will see of the sign may be interfered with by many things such as your windshield wipers or trees alongside the road. Typing error are common if language is being used interactively to communicate with the computer system. Here, in speech problem, noise means distraction, so we have to overcome the noise to understand or the distractions to understand the speech. In image processing, we may search for particular sign and also we see many other things. It may interfere with the thing which we are searching for, but we have to differentiate those images to overcome this problem and get the particular image we are searching for. Understanding is a constant satisfaction. Many understanding takes appear impossibly complex. The number of interactions that can be assigned to individual components of the input is large, and the number of combinations of those components is enormous. But a closer analysis often reveals that many of the combinations cannot actually occur. This natural constraint can be exploited in the understanding process to reduce the complexity from unmanageable to tractable. We know that understanding task is complex, So, in understanding as constraint satisfaction, here innumerable representation of large input make tractable by exploiting natural constraints in understanding process to reduce the complexity. There are two steps in use of constraints in problem solving. Analyze the problem domain to determine what the constraints are, and then solve the problem by applying constraint satisfaction algorithm that effectively uses constraint from step 1 to control the search. Now discussing about how to determine the constraint while we using understanding as a constraint satisfaction. Analyze the problem domain to determine what the constraints are. Here are two types of constraints, static constraints and dynamic constraints. Static constraints, the physical rules they are based on never change. Dynamic constraints describe the current options for labeling each vertex. After determining the constraints, then applying the constraints in analysis problem. What's algorithm? This will always find a unique correct figure labeling if one exists. If a figure is ambiguous, the algorithm will terminate with at least one vector still having more than one labeling attached to it. This algorithm was applied to a large class of figures in which cracks and shadows might occur. Algorithm. Step 1. Find the lines at the border of the scene boundary and label them. These lines can be found by finding an outline such as that no vertices are outside it. Step 2. Number the vertices of the figure to be analyzed. The numbers will be correspond to the order in which the vertices will be visited during the labeling process. To decide on numbering, do the following. A. Start any vertex on the boundary of the figure. Since boundary lines are known, the vertices involving them are more highly constrained than are interior ones. B. Move from one vertex along the boundary to an adjacent unnumbered vertices and continue until all the boundary vertices have been numbered. C. Number interior vertices by moving from numbered vertices to the some adjacent unnumbered one. By always labeling a vertex next to one that has already been labeled, maximum use can be made of the constraints. Hope you all understand. Thank you for listening.